It says we're live. Ugh. All right, what's up?
I'm good, Scott. I'm good. Uh, yeah, it's been an eventful. When was the last time we spoke?
I think
That was last year,
I feel like
right?
it's no. I think it was recent. It wasn't
Hmm.
like maybe 3 months ago. I have to
Okay.
check.
Okay.
I thought it was like 3 months ago, maybe.
Yeah. Yeah. I think 3 months ago. Yeah, but yeah, yeah. Because I hadn't I hadn't switched jobs then as at the time. So yes, it was up to 3 months ago. So yeah, a lot has been going on since that 3 months. So maybe I should just jump right into it, right?
Okay.
All right. So
All
yeah,
right.
I got a job with a company in Switzerland, and we do like full stack F sharp development, and it's been super awesome. Honestly, like you know how they post it on Stack Overflow saying that F sharp is the highest paid uh, one of the highest paid languages, right? Like I can actually see the I can actually see the effect of my life directly, you know. So it's been awesome.
Hold up, hold up. I'm not being disrespectful.
All
You're getting
right.
paid. You're getting paid first world wages.
Yeah, pretty much. Like okay, so I'm being paid roughly like um
I mean, you don't have to give me details, but you're getting
yeah,
paid
yeah,
what a
yeah.
Canadian, American, or Australian would be getting paid.
Yeah, something like that. So let's just say that I got almost is it a 10? No, it's more like 100. No, it's more like a tenfold increase or something like that. So 10x
Congrats.
10x what I was getting before. So it's just mind blowing.
How
Yeah.
does it make you
So
feel? Do you feel like it's been a long time coming, and like, why did it take this long?
yeah, yeah. I think I know why it took this long. Part of the reason it took this long is because uh I'm a prisoner to my own principles, essentially. And at the time, I was a senior manager, senior technical manager in cyberspace where I currently work here in Nigeria. And the job was super stressful, but at the same time, it was really like rewarding. So uh, I was working on a payment platform, cyberpay.ng. I think it's already out. So I'm gonna send you the link. Cyberpay.ng. We were to launch the platform, and it was so like just give me a moment. I don't know why she's calling me. So yeah, cyberpay.ng was super crazy, you know. Let me just send you the link in the chat so you can take a look at it. Yeah, it's we built a payment platform from ground up, and you know, considering the complexity of the domain, you know, handling payments from multiple payment processors and all that, it it was not easy. It was essentially like six apps all put together. So it was like a microservice architecture. So we had different components all connected together. And I was architect at the time. I was responsible for architecting, for building, for like a very good portion of it is actually my work. So at the time, it was more like I didn't want to just leave the payment platform halfway. I wanted to see it to the end at all costs, even though it was starting to tell on even my health as well. Because can you imagine on 31st, right? When everybody was out celebrating New Year and all that, I was just working on it alone. I worked on it till like 9 p.m. Like, no, it was more like 10 11 on New Year's Eve. Really crazy. So, but in the end, it turned out well, and more importantly, because you see, software development is a teamwork. So it wasn't just important that we shipped it out of the door. What was more important was that the rest of the team were part of putting it together, and they could continue after I was gone. So yeah, I think they are currently making a lot of improvements and strides on it, and that's what really makes me happy. But that's the reason why it has taken this long for me to leave the company. I
You don't
motivated by the money. Yeah.
you don't have concerns that when you leave things will fall apart.
Well, I do, but that only happens when like you. Oh, sorry. Hold on. Let me switch this off. Just give me a moment. Yeah. Hello. Okay. Okay. Come back and come and take my phone instead. I'm on video call. Yeah. Sorry about that.
No, we're
All
good.
right. Yeah. What was I saying?
I was asking you. You don't have any concerns that the system that you've been trying to prop up and deliver, and some of the sound engineering decisions that when you leave, things will just fall apart by people just hacking things, hacking
Yeah.
it to pieces.
Yeah. Yeah. So, okay. Since we're having this discussion, I think I better go down the rabbit hole then. Yeah, that was one of the reasons I was so keen on finishing all the major components, right? And finishing all the structures of all the major components was because I there has been some while we were working on it, right? We That was like the third or fourth rewrite of that application, believe it or not, a whole payment platform. so when I was brought into the team, right? Like I said, software development is a teamwork, right? You can't be the lone ranger that's just doing it on your own. Like what will happen is the moment you're gone, someone will just rewrite it. It's as simple as that. So in order to prevent that, I made sure that we like had all those technical decisions, like all those technical discussions up front. So I would explain, okay, this is why I'm doing what I'm doing. This is the this is the reason for this. This is the reason for that, and also to make sure that they also are their input is also part of the design as well. So it's not a matter of me always being right per se. If there are places where I can make like trade-offs or compromises, I would make them as long as it didn't like defeat the overarching structure. You get what I'm saying? So, but more important is that if when members of your team have an input into the direction of a particular product, right? They take ownership of like certain aspects of it. Then you would essentially make it in such a way that they would be less likely to what's the word? They will be less likely to switch. Sure, you get. They'll be less likely to rewrite the code essentially.
Yeah, I get it.
Yeah. So yeah, it's still possible that they would like rewrite it altogether, but yeah, we'll see about that.
So you got this new gig. Are you like the Jeffersons? Did you move now that you're making like 10x what you used to make?
Oh well, yeah, the new job it's challenging. It's challenging to say the least. Like, you have to understand that I used to be the superstar of the team when I was in cyberspace, right? So I used to be the one that everybody would consult. I was that guy, that if they needed to find out, oh, our build pipeline isn't working, or oh, we need X to be done, and all that. I was the person that I was like the last like bus stop, if you will. But moving to the new team and starting off with full stack F sharp, you realize that, man, F sharp developers are some of the smartest people you will ever meet. Honestly, like it's not a joke, and I'm having to go through the ropes all over again, like to get to that level of proficiency. Yeah.
Oh, what exactly are you realizing like massive growth opportunities in? Like what are you realizing that you didn't already know before? Because I mean, you've been doing F sharp for like 3+ years at
Yeah.
least, right?
Yeah. So I've been doing mostly like server-side development. It's client-side that's like Fable and Elmish and all of that parts. That's the aspect I'm still like I won't say struggling with because I've gotten to a particular rhythm at this point, but it's still not like I'm still like there's still a lot more headroom for me to learn, if you will. But more importantly is that it's almost a change of mindset. So we use containers, we use Kubernetes. So yeah, having to deal with that and the workflow around that, microservices and whatnot. So yeah, those are some of the areas I'm still trying to get a grasp of, because you have to understand that like I came from, that's my background, right? Is developing like line of business apps. We just push it and it's a monolith and it just exists on a server with a simple web page with a little bit of Angular JS and we're good, right? But now we're dealing with having to split the components into multiple microservices, having Kubernetes orchestrate all those microservices together, handle our deployments, and on the client side using Elmish, right? Using Fable and Elmish to build Elm style architecture. Okay, you are very conversant with Elm, so the Elm architecture and all that, right? That like the whole thing it's a huge mental shift, if you will. So yeah.
Yeah, I think I'd rather do back end. I mean, I'm still doing like mobile development, and
Okay.
like it just gets annoying to me how things should work, but they don't work based on this platform or whatever. That's
Yeah.
good though. Has
Yeah.
you think without a long drawn out answer,
Mm-hmm.
how relevant is Kubernetes? I don't really hear that much about Docker anymore, but I do hear about Kubernetes. Is this something that's like just a hipster technology that's cool? Or like is this something that is essential when building a serious system? Like I don't really understand the
No.
I don't
Yeah.
I don't understand the argument for containers.
Okay. So I will let me give you the elevator pitch then. So if you allow me. So Kubernetes, right, is essentially the reason you don't hear about Docker much anymore. Docker is essentially how you package your application and microservices. Then Kubernetes is essentially everything else. Okay. How do I explain this? So, what is Kubernetes? Kubernetes really is a container orchestration framework or platform, and essentially all the Google services you use, right? Gmail, Hangout, whatever. They're all built on Kubernetes. And what it does is think of Kubernetes like a football coach, right? His job is to essentially have different kinds of players. So you have, okay, let me take American football because the rest of us we call what you guys call soccer is what we call football.
Yeah.
So, but yeah, so like imagine you have like a quarterback and you have a what are the other rules? Okay, maybe you
You're
soccer.
asking the wrong person. Quarterback, running back, wide receiver. That's
Yeah, yeah, something like that.
the
So
front line. Yeah.
yeah, so imagine those as services, right? So essentially, what? Okay, let me use the one I'm familiar with. I don't really know much about American football, but
Okay.
yeah. So in soccer, you have the goalkeeper, you have the defenders, you have the midfielders, you have the strikers, right? And essentially, it's up to each team to decide how many of what you want, and that's called a formation. So you could have a 4-3-3 formation, which means four defenders, four midfielders, and sorry, 4 defenders, 3 midfielders, 3 strikers, for example. And then it's up to the coach to make sure that each person is, performing optimally. And when someone gets injured or someone gets tired, the coach substitutes the player, right? And I'm sure American football has something similar. So yeah, that's what Kubernetes does. So imagine all the different aspects of your application. Say your database, your middleware, your backend systems are all microservices, right? So what Kubernetes is essentially you give Kubernetes what is called a manifest, right? A deployment file or a schema of saying I need 3 defenders, I need three instances of the DB, 2 instances of the middleware, and 1 instance of the web application itself. And then Kubernetes is responsible for automatically restarting the apps when they die. So if something bad were to happen, being able to if a container were to fail, being able to like restart the container. And if for example there were, it keeps failing, right? It has ways of like instead of restarting it forever, it has like short-circuiting logic in it. It also has logic for seamless deployment. So say, for example, the app is currently running and you want to upgrade to version 2 of the app. So what it does is it will take essentially, let's say the state, all the V1 containers are running, and then version 2, you tell it that, oh, there's now version 2 of this application. So what it will do is it will start by killing off maybe 1 or 2 containers, then deploying V2, then routing the traffic, some of the traffic from V1 to V2, monitoring the V2. If the V2 is still alive, so that's where you get something like liveness check and probing and all that. And if V2 is healthy, then it goes ahead to finish the deployment. That's called a rolling deployment. And it handles that seamlessly without the service ever like going down or anything like that. So if you think about it from a infrastructure guy, right? Kubernetes doesn't really, from a developer standpoint, right? It's not really the developer's concern per se.
It seems it's more, if I may, this is kind of what I interpreted from like your. I'm tired this morning. I was at the bar last night. It sounds like Kubernetes does extremely well if you use it as a tool for resilience engineering.
Exactly.
Okay.
And another way you should think about it is essentially what the cloud gives you, what maybe Microsoft's Azure App Service or what, there are services like that. What those give you, Kubernetes is essentially giving you the same thing, but you get to control the whole stack end to end. So for example, if you feel like Amazon is too expensive and you want to move to Azure, it's a point and click thing. In fact, it's just a single file. You just move to Azure and your entire infrastructure will move all the way to Azure. And if you decide maybe Google Cloud is the best for you, you just take that, your single file, and move it to Google Cloud, and all your infrastructure will move to Google Cloud.
It sounds like it's infinitely configurable.
Oh, you have no idea.
Is it like, I mean, like, I know it's apples and oranges, but is the configuration kind of like what I would go through with WCF?
Okay. Yes and no. Okay. So yes, in the sense that, in WCF you would set up, what was it called? Endpoints?
Yeah, right? you have all these types of bindings like TCP binding, HTTP binding, and a couple others. And to me, WCF was infinitely configurable. But like for most people, I would say for like 85 to 90% of people, we just want to do like just basic like connect a device to a web service. I don't care about security settings at this point. I don't care about a lot of things. I don't care about the protocol. Like I just want the thing to work. But WCF required like intimate knowledge of, I would say, network protocols and bindings and all the other stuff. So it was like it required a skilled developer to just create a CRUD application that relied on web services. And then when Web API came out, it pretty much blew away WCF because WCF it was solving problems that I think people didn't really have at the moment or that they actually cared about. It wasn't abstracting away. I think WCF didn't have the proper abstractions for people to just get things done, right? So I didn't mean to go off on a tangent, but when Kubernetes, I was kind of asking is it infinitely configurable where like you could literally take a certification that's 500 pages of training material, just be able to understand the settings and stuff like that to get something up and running and all the different responsibilities, all the different layers of the architecture or the protocol, etc.
Not really. So I think it's important to frame the discussion a little better, right? So what Kubernetes is trying to do, because if you look at it, there is this new idea of DevOps, right? Where you are bringing the operations people, the IT infrastructure people, and the developers together, right? You've heard the statement that if a developer has to answer a 2 a.m. call to fix an issue in production, then your production issues will vanish. I don't know if you've heard that before. Yeah, so
it makes sense though. It's putting the responsibility on them to dot their I's and cross their T's and do thorough testing, where majority of developers, they don't believe that their job is to test.
Yeah, and even thinking about like, where is my application going to run? What are the constraints? How do I develop an application in such a way that after I've deployed it, it's infinitely configurable to suit whatever demands I face? So like we faced this in CyberPay when I was building CyberPay. So say, for example, you wanted to develop your app such that you could have multiple environments, dev, test, production, QA, and you want all those to have different configurations, or you want all the services to, so you want a situation where each component doesn't know about every other component that is plugged to, that the interfaces are well defined. Because when you hard code like relationships, right, it makes it difficult to replicate across multiple environments. So say, for example, if I had coded the location of a particular service, right, it would mean that by the time that service goes into production, there would be no way for someone to change the configuration of how it locates its own, service or something like that. Am I making sense? I think I'm going off on it here. So that's what Kubernetes brings to the table. Really is giving developers and IT professionals, like so the operations people, the same tools, the same environment, the same what's the word? Yeah, the same tools pretty much to manage essentially the state of the application. So on my dev machine, for example, I can essentially stand up, my production environment, what my production environment looks like. I can stand it up on my dev machine, test it out, and I would be able to see like production level behavior on my own machine. And knowing fully well that if it works on my machine, I could take exactly my current deployment and push it to dev or staging or production, and to be exactly the same. And there's a very high level of predictability as to what is going on with the system. So yeah, pretty much. But at the end of the day, what Kubernetes gives you is essentially the ability to build like platform as an infrastructure. You know how the ability to have your own custom platform as a service, right? That's essentially how I see Kubernetes. Abstracting out essentially the cloud layer out of your platform. So if I was building a payment platform, for example, I know this particular CyberPay wasn't built on Kubernetes though, because we didn't have the skills at the time. But it was built on Kubernetes, right? We've abstracted out the cloud platform, which means, like I said earlier, I could take the app and deploy it on any cloud, and I'm sure that the behavior, or even on-prem for that matter, and I will have all the benefits of scaling, of resilience, of fault tolerance, of rolling deployments, etc.
Okay. So, where are they? If you were to look for jobs, is it called a Kubernetes developer? Or like
Okay.
what is it called? Like, and are they handsomely rewarded?
I think it's still, again, it's DevOps. So think of Kubernetes less like think of it more like Git, right? And less like a particular, paradigm, if you will. So if you really want to, let's say we wanted to really go with domain-driven design, right? And we wanted to have a microservice architecture. Although, in the truth is, in my opinion, microservices is not for everyone. It's only for people who are building like, I don't know, if you're building really really large, if you're building a very very complicated or large system, then sure, go microservice. But other than that, most people can get away with a monolith. So I'm not saying that you should use Kubernetes for all your projects, but if building a platform is what you have in mind, right? Kubernetes is a tool similar to Git, so it affects your entire workflow, even down to your Visual Studio experience, right? You no longer get the luxury of hit F5 to run or something like just it. No, you could still do that, but it's not. I should pick my words carefully. It's okay. It's like this, right? Think of Git, right? Git is a particular tool that you use to manage your source control, to deal with source code changes, right? And it's built into your workflow. Containers, on the other hand, is an extension of that. So it's not enough to just say, oh, I've checked in the particular code and it works on my machine, right? In the container world, you would build essentially a container, which is an image, essentially. And that image represents your app as the way you built it. So you can test that app in isolation of your environment, test it, know that it works very well, and whatnot. And then you now deploy that same container to both dev, QA, and production. What Kubernetes does is it gives you the ability to orchestrate multiple containers together. So say, for example, I had a ordering service and I had an app that was, single responsibility, handling, storing orders, right? I had maybe a fulfillment system. I had maybe a, okay, let me use the CyberPay analogy, right? So in CyberPay, you have the settlement system that's what's responsible for giving people their money. You have the merchant portal. You have your the admin. You have the merchant, admin, settlement. You have the wallet. You have quite a few systems, right? So with Kubernetes, each of those systems will be a single image, a single container, a single set of apps and services. And then what Kubernetes does is the networking of, like, standing up all those containers, networking all of them, service discovery, allowing containers to be able to talk to other containers, and making sure that the containers, if they die, they get resurrected. And if you try to do your deployments, that the deployments happen in a way that does not disrupt service. Because as you can imagine, the payment platform, even 5 minutes of downtime translates to huge losses in revenue. So, yeah.
That's sweet. I guess now I have to buy a book on it. How quick is it to do a hello world? Does it take half a day?
Maybe, I don't know, if you have the time, I could do a hello world right now.
No, we could do a different session later on it.
But
I mean, I'm kind of like interested now that you kind of described it, because I wanted to get into like Chaos, aka Resilience Engineering.
Okay.
Just because I don't really know of too many people that are like technical authority figures in that space, and maybe I could carve out a niche in that area. Just because I'm in love with test automation, regardless. And so the way that you describe the value of Kubernetes kind of makes me want to practice it or play around with it for the next couple of weeks. So
So to be honest, I have a very strong inkling that in the next 3 to 4 years, Kubernetes will be the
de facto
I don't know.
standard.
Yes, because okay, so let me just give you a history of how it came about, right? So I know Google had an internal system that they use, because you can imagine if you are at the scale of Google, you can't afford Google.com can't afford to be down, not even for a microsecond. You get, so the scale of the problem they have is on another level, right? And to think that some people just use Google.com as a way of knowing whether they are online or not. So they just check Google.com to see if, oh, am I connected to the internet? So yeah, from a reliability and resilience standpoint, right? The bar is high up there. So they came up with like a platform. I can't remember what the name was called. It was called something. Was it Borg? And they had to, like, they got a lot of feedback from that one. You know how when you're developing an app for the very first time, you start to see problems you did not anticipate, and then they built all those their knowledge, or they built all that knowledge and learnings from that into the platform, that Borg. And then Borg was later changed to something else before they now decided, okay, let's create an open source version of what essentially is our internal infrastructure, and that is Kubernetes. So Kubernetes does it pretty much is, I don't know how to explain it, but
The
they've
dog
thought of,
food of Google.
yeah, they've thought of everything you can ever imagine. They thought of SSL termination, they thought of handling microservices, they thought of scaling, they thought of a lot of things. Okay, how do you check if your service is healthy? How do you know if something goes wrong in your service? How do you automate sending notifications to your ops people that, oh, something bad is happening? How do you handle machines failing in your cluster and all of that? They've built all of that into Kubernetes. So as a result, Kubernetes is so robust as a tool, as a technology, that it's, to me, feels like what many companies, especially enterprise companies, that still have a fetish for on-prem.
You're laughing at them.
yeah, yeah. So especially enterprise that like on-prem a lot, like it's going to be a big deal. Like, it's clear in my mind that, you know, as a developer, learning Kubernetes is probably what the next step should be. Plus, I think another advantage that Kubernetes and containers gives you is that this whole argument that goes on in enterprises where, oh, we're a C# shop and we can never use Haskell, for example, because we don't have the runtime, we don't have the tools to, we can't deploy Haskell to Azure. All of that goes away with Kubernetes, because essentially all it takes is for you to write whatever, write in whatever language makes you happy. If it's Haskell that makes you happy, fine, and just deploy an image, and then you will be able to run it as part of your infrastructure. So the whole idea of locking you to one runtime, one platform, that whole thing goes away with container applications and Kubernetes. So I think moving forward, many companies are going to adopt it. Like, I have no doubt in my mind.
I'm looking at Kubernetes on Amazon.com. Is there any like the Kubernetes book? There's actually a book called The Kubernetes Book that has
Are you
160
serious?
ratings.
Wow.
Like, I mean, is, is there any book that you recommend that like eases you into the pattern of what Kubernetes is attempting to solve?
Okay, so I think, okay, this is it, right? The guy who wrote the Kubernetes book, right? His name is Nigel Poulton, right? And I don't know, but he's kind of like my favorite Pluralsight author. So I'm not a book guy. I'm more of a visual video guy. So he it was his course. I watched his course on Kubernetes, and that was what gave me a very good idea of how all the pieces come together, right? So if I have to recommend a book, I would say that book, that the Kubernetes book. Speaking of which, I may actually just purchase it. Though. I may even buy the two books. He has one, Docker Deep Dive and Mastering the Kubernetes book. Add to cart, 15 bucks. Okay. Shut up and take my money.
He's actually using. Is this where you provided the analogy from? Because it looks like there's an example of a soccer game.
Yes, exactly.
Okay. All right.
Exactly. That's where I got the analogy from. So
I'm gonna pick this up.
and the guy is really good, right? So the way he explained it on
I just bought it.
all right, cool. I'm also getting my own copy as well. I'm getting did you buy the wait, hold on, did you buy just the Kubernetes one, or you should have gotten the one with Docker as well?
I don't even hear people talk about Docker anymore.
No. See. The reason why people are not talking about Docker is because now Docker has two components, right? There's Docker Swarm, then there's the Docker like container runtime. So pretty much people are now using the container runtime only. They are not using the Docker Swarm essentially. So the reason you don't hear Docker is because it's pretty much now just part of the infrastructure, if you will.
Okay.
Similar to the same way you don't hear people talking about Git, because everybody just assumes that Git is what it is. Make sense?
Yeah, it does. It does. So that was a lot of information.
Yeah.
Are you participating? It sounds like you're very busy. Are you participating in the F# mentoring program?
Not at the moment. Not at the moment. So, like I told you, moving to this new position, right? To getting this new job. I just started, I think, January this year. So, started 2019 with the new job. So, I've been trying to catch up essentially, and that catching up has been taking most of my time. But I think maybe towards the middle of the year, when the next mentorship comes around, I'll definitely join in. But I really enjoyed my last mentorship with Avni, right? And yeah. So, but it's like you.
That's the machine learning lady.
Oh, okay. No. That's the F# compiler. There's also the machine learning here from Matthias Breinwinder. I really enjoyed his own as well too. So,
okay.
So which one are you doing?
What's up?
Which one are you doing? Which mentorship or?
I'm doing domain-driven design.
Oh, nice.
It's cool. It was supposed to be like Wednesday and Sunday sessions is what we agreed upon. Today he canceled, but we did a session on Wednesday. So
okay.
It's cool. I wish I could make a business from teaching.
Well, you could, maybe, I don't know, you could be a Pluralsight author, I guess, because I think there's a lot of there is a lack of F# materials on some of these, especially F# video tutorials. I know I started something, but I still plan to get back to it. Just the whole career shift and everything has, so I put a pin on most of that, but I plan to do that. I also even plan to start an F# meetup here in Lagos. So
This is my ignorance. There's like, honestly, I'll probably answer my same question. I was gonna say, you think there's demand there? But then I'm like, I don't even think there's demand in Miami.
Really? There's a strong demand in in Lagos. Yeah. In fact, most of my friends who I talked to about it, they're like, "When are you going to start the meetup? When are you going to start the meetup?" And I'm like, "Very soon." But I just need to get my life in order first.
Have you ever
So,
ran a meetup before?
no, no. But if you remember, I used to teach. I used to teach. I used to teach. What was I teaching? Let me see. Am I sharing my screen? Okay, no. Okay.
No, that's me.
Okay. I used to teach .NET development. If you remember, that was I think 2 years ago. I mean last year. Yeah,
Yeah,
I think. Yeah.
I ran a .NET meetup when I lived in the Philippines. Um,
Mm.
and so I would say that one advantage of being an organizer of a meetup is
Mm-hmm.
you assume power and influence, and people are going to you're like the main artery when it comes to people
Mm.
that want help. Like when it comes to recruiters, and you can
Mm.
negotiate with consulting offices like, hey, I'm looking for an office to hold a meetup group. We're probably going to have like maybe three top experts within the city, but then we'll probably have like another maybe eight, junior level talent. And yeah,
Mm.
I would like pizza to be provided, and this that, and the other. And it was a cool experience. You get to meet a lot of
Yeah.
people.
Mm.
Yeah, the one I was running, I actually hijacked it. When I moved to
Mm-hmm.
Manila, the first thing I did was look for meetup groups for .NET, and I found one, but it was pretty much dormant, meaning that
Mm.
it wasn't active, and I just took over it, and I just paid the bill. And then the original organizer was like, "Hey, maybe you should run things through me, about how we plan it." And I just ignored them, and I just started holding sessions. Like, no, you had your chance, but thank you for the audience, since
Yeah.
I don't have to build one myself. So straight power moves. No, so
Yeah.
like I'm sharing my screen, but like,
Yeah. Yeah. Like I've been looking at your code. It looks like a work of art.
uh, so here's the well, thanks. Here's the I think I might have. I like Visual Studio because I could just say scope to this. So
Mm.
I'm working with a guy in New York City, and he
Okay.
works at a loan company. And so, who would ever thought that over 3.5 years ago, my declaration to learn F sharp, 3.5 years later, I would be a mentor, right? That's crazy. But anyway,
Yeah.
so like I'm teaching him my experiences, my practices of domain driven design that
Okay.
was heavily inspired by Scott Blashen's book, but
Yeah.
I kind of went down a different channel just because I attempted to practice what the book had preached, but it wasn't really working out for me. But
Mm.
so far, this is pretty much my de facto like setup. Whenever I start a project, even if it's a legacy application, like I do this
Mm.
all the time now, where I'll I'll automatically add a folder that represents a domain, hence
Okay.
this loan folder up here,
Mm-hmm. Yeah.
and I will have a specification folder right under it that's going to be a specification library and
Mm-hmm.
a test library.
Okay.
The specification library will have two different files, operations and language. And
Okay.
let me zero in on the specification library. And it's pretty much there's going to be a specification library for every single domain. And
Mm.
how do I scope to this? Let me do this right here. And so I pretty much learned at least what works for me is
Mm.
I'll do type driven development, but instead of the identifying all the nouns and doing system design like that, where I'm identifying all the nouns, all the different objects or
Mm.
classes that are going to be used, and then I try to figure out the operations. I do operations first, where
Okay.
I define these function types. Like validate is going to take an unvalidated application and it's going to output a validation result, which is essentially a valid application or an invalid application. And
Okay.
I find that when I do behavior first,
Mm.
without thinking about nouns, but I only identify behaviors and what those inputs of those parameters are going to be and what they should output, it's going to flesh out my ubiquitous language for that particular
Mm.
domain. And that's pretty much
Mm.
the exercise that him and I are doing for this loan specification. And so that's
Huh.
pretty much so far we identified. See, this validate is pure domain logic, meaning it doesn't rely on any IO.
Okay.
But I mean, it's probably smart for me to do a module call this IO and then say equals, and then under that namespace, all the function types that are going to be doing IO. It's easier for whoever uses the API to
Mm.
know that it's probably good for them to do try catch blocks. So that's pretty much it. And then what do I do? Click on home. The first part is type driven development, which is what I was doing right
Mm.
here. And then
Okay.
I test out my type driven model by doing test driven development, which is pretty much up here. And I just fill in the blanks. So this is the specification. Oh shoot, where am I at? The specification is compilable, is a compilable specification, but there's no
Mm.
interpreter. But then my automated test is the interpreter of that specification, if that makes any sense. And
Huh.
so, yeah, that's pretty much the exercises that I've been doing with them. And
Wait,
it's
hold on. Maybe let's backtrack a little bit, right? So, let me see what you have in that language. So,
you want me to zero in on anything with the specification?
no. Open the language file. Just double click it. Let me see what's in language.
This language file was literally flushed out by identifying all the operations up here.
Oh, I see.
So I identify all the operations of a domain, and then
Mm-hmm.
just the act of declaring the operations and what they're going to take as input is going to identify all the types that I need to create,
To
which I
create.
then
Okay.
throw in this language
Oh,
file.
okay. Okay. Huh. Okay. So I just learned something now. Typically, the way I do it is this file you call language, I would call it domain.fs, right? So I would essentially put all the entities that I need with all the type names and all that, right? But
Mhm.
I don't have this operations file. So like what you do is you essentially give all the different operations you want to do names, right?
Yeah.
And yeah, so but these are just still type definitions of the operations.
This whole
Do you have it?
specification is nothing but type definitions. There's no implementation. It's just a
Okay.
specification. So if you look at, I didn't mean to cut you off, but if you look at
No, it's fine.
the actual test, you can look at this again, the operations and language as a
Mm-hmm.
specification. Really, operations is a specification, and language is
Yes.
just behind the scenes, right? But operations is the
Mm-hmm.
spec, and
Mm-hmm.
then your actual like implementation, which for
Mm-hmm.
me by default, my first implementation. Uh, Maybe I should change the word. Okay, I have a
Okay.
specification and I have an interpreter. Now, if you look
Okay.
at this specification is essentially algebra. All right. So now we're thinking about
Okay.
mathematics, right?
Yeah.
So this is literally an equation saying
Mm-hmm.
that a present offer function is going to take an applicant, a valid application, and it's going to return a result which is either successful or not successful. And if it is successful, there's going to be one type, else it's going to be an error.
Mm-hmm.
And so, like, this is essentially the groundwork for encouraging the compiler to enforce the spec for any implementation that
Mm.
is supposed to implement, or should I say interpret, the spec. right? And so
Okay.
the implementation is this loan test. And so this loan test is essentially an interpreter for validate, right? If we look at validate, if I hit F12 on here, validate, shoot, I did something wrong.
Oh, I see. No. I think I get it. Yeah.
Yeah,
So,
yeah. Validate output. I did this wrong though. What I should do is this validate is really based off. It's not wrong, but the whole point of this is to make your functions implement a function type. And so what I should have done, and maybe I'll comment that out and then do it over again, is shoot. Give me 1 second. What I meant to do is something like this, where what's wrong with my keyboard? Where I do something like that, and then Control KU, and then I have this validate right here, and so it's going to output a validate function, which of course isn't being recognized right now, and well, that's because there's an indentation issue, and then Control boom.
No, check. I don't think that was the name. Was it called validate?
It's called validate, and it's under loan.operations.validate. So this should work.
Okay.
So maybe I do loan.operation. It doesn't.
I think you need to open, just open the namespace in the loan.fs.
Well, I thought I already had that opened up here. Oh, you're right. Okay. So it should be open. My typing is off. Open, and then it's loan.operations. So loan.operations. And so now my validate is right here. And so then I do a function. I'll say wildcard for right now. And then that means I can get rid of these parameters right here, because this is going to do it down here supposedly. And that validate takes a applicant and a application. So I say applicant, and then over here application, and then for whatever reason I'm still getting, it says too many arguments. So I'll figure this out later. Unless do I need to recompile?
Yeah. No.
It says
I think
that should.
Oh, check. It's. Oh, okay. I think it's taking only one. So go back to your validate. I think your validate takes only one.
Check. No, it takes two. Oh shoot! Yeah, you're right. Hold up. Oh yeah. You're right. My bad. All right. So I was looking at present offer. So unvalidated application. So that. There you go.
Yeah.
And over here is the. Actually, I could just do this right here. And to make a long story short, so now I could delete this distraction right up here. And come here. And so this is the specification. The validate is a specification where it's compilable documentation or a compilable specification. And then this is the interpreter of that spec. So, and that's pretty much the exercises that him and I are going through.
Okay, so say for example, you were to plug this into like a mobile app, for example, or a web app or whatever, right? Where would the implementation sit?
Okay, so I have that.
Okay.
So this is a make-believe Uber app.
Okay.
And it's Xamarin Forms and F#. And it's on my GitHub page, but it's following the same type of like structure with like I have specification libraries and then I have interpreters. I don't know what this is over here, but if I go over here, you're asking where's the actual implementation at?
Yeah.
So the actual implement, well, I could show you by referencing. So this ride has a specification. So if I go to operations, then there's a request price. And if I hit Shift F12, is it going to be smart enough to give me? Okay, so I have one example is my test API, right? So first I do type-driven development, which is this right here, but then I do test-driven development, and so I'm like mocking all the stuff out, which is just kind of like what you saw in the last example. But if I answer your question, this is what I found is all this stuff is going to be IO related, right? The request price, find driver, all this stuff sounds like it's like a web service. And so this is going to be in another library that I usually call people call it the data access layer. I'll call it a data gateway.
Okay.
But I don't think I have a data gateway library in here. But in my other solutions, I do, because this is just this isn't like anything that's in production. This is more of a long-term code kata. But if I were to close this out, I would essentially return it back to our example over here. I would essentially create a library, and then that's a F# whatever, and then I would call this loan.data gateway, and that's a library. And then so I have that in here, and so then I'll have something like I don't know, whatever, or whatever you want to call it. I don't know. I always get confused because the compiler in F# complains when you use a file name that has the same name as the project name. I'll call this common. And so then module, I don't know, I'll call that common. And so to answer your question, if we were to, there's actually like kind of two answers to your question. This validate is pure domain logic. So that has nothing to do with the data gateway because it's not doing any IO. But that would be in just loan, and then create another project called loan.domain. Kind of like what Scott Vlashin's book was advocating. So loan.domain here, and then I could call that common, I guess. Okay. And then say module common. And in this case, we have this, where am I at? Give me 1 second. We have let validate equal validate type, which I have to add a reference to my specification. So then I do loan.specification, and then I probably, can I do control dot? Will it find it? Control dot, will it find it? Do I have to build everything first? I just want to get errors because this doesn't have the implementation yet. Shoot. What just happened? Validate, and then I say validate control dot, still doesn't find it. So then up here I say open loan dot I thought I added a reference here. Hold up. Oh, loan.domain. I was in the wrong part. There we go.
So there's something I would have liked to show you, right? Because this whole thing of domain-driven design, I really need. I don't know how much time do we have left, because
I'm good.
Okay, because I think I would really appreciate it if you could help me out. Like maybe we can rationalize our thoughts on certain things. So there's something I want to do, right? I want to show you essentially like the traditional like C# way of domain-driven design, right? How we typically do it in C# and whatnot. Considering that both of us understand F#, the question is how do we translate? Like I want to explain where everything, like I'll show you a full application end to end, and show you where everything is. Then we can now discuss like what strategy or what approach we should take essentially. So just give me a moment. I am cloning some code.
Should I stop sharing mine? Cody. Can't hear you. Oh, this is pure. What up? Cody, I don't know where you went. Hello. Are you still there?
Yeah.
Something happened with the audio.
Yeah, accidentally closed Chrome. So, but I'm back now. So let me just give me a moment, right? Can I share my screen so that you can kind of see what I'm talking about. So
hold up for 1 second. I just want to get this thing to compile real fast, and then I'm turning it off.
All right.
Unvalidated application. I thought that this over here was called a invalid application, which over here is a application. That right there should be. And this was an example of how you implement this. In the loan domain, it takes safe or pure functions. And then in the loan.data gateway, it's the functions of the specification that rely on IO. So
okay.
All right, I'm done. It was a little bit long. All right.
All right.
Stop sharing.
Okay, let me share. Sharing my own screen. Can you see my screen?
No.
Not yet.
Yes.
All right. So let me close this. Let me save this. Desktop stuff. All right. Let's take a look at. I will need to increase the size. How do I do that? Zoom. Anyway, so you see the folders on the right. I wish there's a way. How do you zoom in Windows?
I don't know if you could zoom in on the Solution Explorer. I think
there's magnifier. All right. Okay. Good. So you see what's here?
Yeah.
Okay. So this is essentially how a typical C# application is, wired together, right? So we have our core domain. We have the infrastructure, which is essentially what you are calling IO, and then you have the web app that sits on top of the two. So from a dependency standpoint, right? The core doesn't depend on anything. The infrastructure depends on the core, and the web depends on both core and infrastructure. Do you get that? All right. So if we come to controller, right? So let's open, say, account controller, for example. Let's see. Let me zoom out a little bit. So, but here I can just simply increase this to say 200. Okay. Now, looking at what we typically do is we inject uh, uh, what is called a manager, right? A manager has like the core business logic. Okay, so after injecting we inject it via like an interface or whatever, and then in each of the methods we just invoke that manager. So let me show you. Count. Oh, it wasn't even used here. This is not a good example. This is not a good example. Okay, hold on. Wow, this is some old code. Anyway, but the point I'm trying to make here is that we would essentially inject one of these interfaces, right? Okay. So we would inject something like this, and it would have all the core business logic: create user, delete user, update user, get password hash, set password hash, remove user from role. This operation is kind of like what do we used to call it? It's kind of like what's the word again? Yeah, result type, exactly. So let me quickly get package manager. It's been so long I did C#.
I can't stand. I have to be careful. C# is cool when I'm doing like MVVM, like when I'm doing like value converters and stuff, but I hate writing it for business logic.
Yeah,
I feel like there's so much I have to write for things to be rigid.
So in this particular case, right, we were able to like get some level of, so essentially the I account manager just has the interface definition. So different this is like result of user. So the failure is always a string. So this is returning a result of string, result of Boolean, and so on and so forth, right? Now, the managers here is the pure business logic. So this would be equivalent to, remember in F# you have the result computation expression where inside you could put codes that could, you could put code that could fail, and then it wraps it in a T result, in a result of success and failure. So it's something similar. We wrap all the business logic in something like this. So for example, create user would first do some validation, then it would check to see if the user exists by calling these queries, right? This query is like the input output. So this is I account query. This is the part that actually does the calls to the database. And each method on this interface will translate to a single database operation, right? So this will translate to select star from users, where user ID equal to whatever user ID is here, right? So again, this is also an interface and all that. And then we now have inside the infrastructure, right, is where we now implement, this is where we now implement the database call. Then we now inject our actual DB context, and then we now write the actual implementation of just the IO. So no validation is done here, nothing. Just IO is done in this interface, right? And as you can see, how it's assembled together is with a dependency injection. So when we inject this I account manager, it would inject the implementation. So let me, this is really old. Wow. This code is like a year old or something, if not more than. Anyway, yeah, so let's go to, where's the dependency injection? Okay, good. This is where the dependency injection is now put together. So you now have your DB context that you inject in request scope, and then you now inject, you now specify that, okay, I account queries maps to this account queries, and I account manager maps to this account manager. Does it make sense?
It does. I'm very anti IOC containers, but I'm understanding.
Yeah. So the point I'm trying to get at is, this is essentially the world I'm coming from, right? So the question is, how does that translate to, the functional world of domain-driven design? So one of the approaches I used in some of my older F# projects was to get rid of this IOC container, right? And I would essentially just in the startup or at the point where I'm starting the application up, I would generate the interface by. So in my business logic, I would have functions, right, that I would partially apply with the dependencies. Then I would now, how do I describe this thing? I need to describe this thing to be. If I don't show you the F# implementation, it won't make sense. So essentially, I would still inject an interface here in the F# implementation, and I would still just invoke the method, invoke methods of that interface. However, at the point where I'm constructing the interface, that's where these methods. Okay, hold on. That was account manager. So essentially, these methods you see here, right, would I would essentially like build, like using partial application, I would build a function that I would actually just attach to this account manager that already has the DB context and all the other information as to how to implement this create user, and then pass that to the controller, right? And I would build that function from a combination of, okay, I think I have this. Just give me a moment. Let me get that code. I think it's important I get that code. I think I have it here. Yeah. GitHub. Blah, 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 blah. I don't have the .NET Core version. Okay. So clone or download SSH. Let's quickly get this out of the way. It's clone. And I'm cloning it. Shouldn't take too long. In fact, I think now, looking back, that's the one I should have showed you. I shouldn't have even bothered with the C# implementation. Okay. Explorer, Lumia. Yeah.
Yeah, I really despise doing business logic in C#. And I only say that just because I'm pretty comfortable in F#, and so like every time I see like exceptions being thrown, I like cringe.
Okay. So, this should get better. Let's type magnifier. Yeah. Step. So let's come here. Yes. This pretty much explains everything. So let's look at. So I'll explain everything. The web here. This is just because if you remember back in the day, there was no easy way of doing web applications with F# projects. It was strictly backend DLLs you could develop with it. So I had to create a separate C# project just to host the TypeScript and the HTML files here, right? So you can ignore this. But essentially, it's the same thing. Like I mentioned before, we had our infrastructure, we had our HTTP, which is the API, and you had your domain, right? So migrations was how we did what do they call it? How we did database migrations. I'll get back to that later. But since I've explained this, I can now exit this magnifier because it's kind of slow. Yeah, so let's head over to domain. Now, under domain, right, you have your railway-oriented programming. So we just wrote a simple T success, T failure, with bind, with map, with try catch, with ignore, and so on. Then we now had our models of domain, if you will. So we had our error, which had product not found. We had our quantity type. We had our product type. We had our inventory, which has product. You have your cart, which has a user ID and a list of items. You have an order item, which is another item of a product. And then you had your order, which had the order ID, the user ID, and a list of order item and quantity. So I think this is kind of clear, right?
Mm-hmm.
All right, cool. So now let's head back to, okay, this was even blank, managers. But let's go to the HTTP. I think this makes a lot of sense. In the startup, the CS, we had, this was where we were doing our configuration, database migration, custom error pages, map attributes, blah, blah, blah. Let me quickly install this, I think. Package manager console. Anyway, whatever. what was I trying to get at? Okay, yes, this is what I'm trying to get at. Now, do you see this controller? So we have a product controller here, we have an inventory controller, and we inject the business logic directly into the controller such that we could just come here, invoke it, and just check whether it succeeded or failed. If it succeeded, we just said okay of the product. If it failed, we just return bad requests. Make sense?
Yeah.
Okay. So, but in the domain itself, right? Because the question is, where is this get inventory coming from? Right? This is where it's coming from. So we had a composition route here where, depending on the type of controller, we would instantiate it differently. So, for example, if we were instantiating the inventory controller, we would essentially do this. Okay, yeah, we use the what do they call this feature of F Sharp? This lovely feature.
Active patterns.
Active patterns. Thank you. So what we would do is we would, if we matched the controller, we would essentially create our SQL repository. We would now pass it to the what you call data access or data gateway method, this fetch inventory. You can find it here. So this one, we pass the, what do they call it? We pass the DB context, okay? We write a simple query that just pulls out from the DB context. It maps it and, creates it as, sends it back as an array. So this function here is what we would essentially just inject into the controller and then return that controller back. And we did that, and we did the same thing too for product. Although product, we didn't inject anything. This worked, but what we noticed was if your business logic, say for example, this particular controller had like 5 different controller actions or like 10 different controller actions, similar to what I showed you in the C#, right? You wouldn't want to have a very long list of functions here, right? So, and another word for a list of functions is a class, really, or rather a static class. So what we did was to have essentially an interface that had just the list of all the different functions that we wanted to use inside of this controller. We will put that here. And at this point, this infrastructure point, we would essentially just create a record type. We will do something like this. Something
Yeah,
like,
I think I already know what you're going to say because I do the same thing. I have a record type of functions.
Yes, exactly. So that's what we would just simply, you get that already. We'll just simply inject it into the controller and move on, right? Now, the challenge. Okay, the challenge with this was essentially what not Scott Lashing. What's the name of the other guy? Ploid or DK. That would be
Hold on,
what's his name again? This guy that we follow.
Tomas Petracek.
No.
Mark Seaman.
Mark Seaman, thank you. So yeah, Mark Seaman was essentially getting at something like this, where if you look at this code, right, especially this part, right, what we are doing in essence is just going straight to the data access and injecting the data access. There is no business logic, if you will. Okay, so this place here where we are constructing it is the business logic, but there's no real clear separation between the pure and impure stuff, the domain and the non-domain, the logic and so on and so forth. So this project, I know that because there were 2 of us that were working on it, me and a very close friend of mine, maybe. We got stuck here and we just gave up. So after all this my explanation, what I'm trying to get at is, given what I see you having like functions that represent, like giving different operations names, would you put how does that work together? Like, where would you put it? Would you put it in domain? Would you put it in infrastructure?
No, the way, if I'm reading you right, let me try to start over. So when I'm with emphasis on practicing domain-driven design, any operations that are IO or unsafe. Let me put it like this. You remember when I was showing you my specification library?
Yes.
The specification library is going to have the majority of the function types that are declared there are going to be IO, right? Because it's pretty much the domain. But there's going to be also some pure functions that may deal with transforming, or shall I say, converting a data structure from one type to another, right?
Okay.
So
Okay.
I have a combination of conversion functions, or shall I say transformation functions, but the majority of functions are IO specific. To answer your question, the client of those function types is going to be, if you're talking about web, is going to be your controllers. So what happens is this: within your controller, your controller is going to be a client to anything that's IO. It's going to invoke some type of IO operation, and then it's going to pattern match on whether that operation was successful or a failure. And so there's a term that you've probably heard before, an imperative shell over a functional core. And so your controller is imperative, right? Because it relies on side effects to basically route information to the UI. And also it's going to be invoking your infrastructure libraries to write data to disk. And so to make a long story short, your controller is going to be the client to your function types, right? Your domain functions. And it's always going to be calling your domain functions and always going to be asking, was it successful or was it an error? And that's all it does. I could show you an example, a production example, or a real business example, but I can't because it's for an actual company. But like even the Get Right app,
that's something similar to this, right? Where the controller just calls this function and then checks if it was successful or not.
Yep.
Am I getting it?
Okay. It's basically your controller is going to be properties. It may have a load operation when it first gets instantiated, and after it's instantiated, it calls load. That load will perform a query, and then it populates some collection of items that are to be rendered. But it's essentially your controller, or in my case, because I do mobile development, my view model is going to be the client to all domain operations, whether they're pure operations or IO operations. And all they do is call these domain operations, and then based on the result of those operations, were they successful or were they error? And they just perform the side effects. They render it if it's successful. Whether it's performing a navigation or whatever else. Else, if it's an error, it'll probably call your infrastructure code again to say log this error, or it'll perform a navigation to some error page saying, oops, something happened. And that's all it does. So to make a long story short, I would argue, based on my personal experience, that your controller should be the only client to your domain functions within domain-driven design.
Okay. So, but how do you now separate like the pure and the impure aspects of your code? Because,
I'm sorry.
Yeah, because like for example, the idea here with this one is that the pure code is here, right? The impure code is in this assembly, and the pure code is in this other assembly. Although there's really nothing here, really. But yeah,
right. But your controller is still I would argue that your controller should still be the client to both of them. So like it's good that you have a separation of IO. Assembly that has IO versus assembly that has pure code. But what I found in my experience is your controller will be essentially calling your pure code to do transformations, safe transformations. Like, for example, when it wants to validate a form, it's going to call the validate function, which is a pure function, and it's going to pass in an unvalidated form, and it's going to return a result of validated form or unvalidated form, right? Whatever that result is, then it's going to take that result and pass it into an I/O operation, right? So your controller is essentially taking data, safely transforming it using pure functions, and then the output of that pure function is going to feed into an I/O function. That's what my experience.
Okay, so say for example, I needed to do 3 I/O operations, right? Or let's make it 2 I/O operations, and the second I/O operation is dependent on the first I/O operation. So say for example, I were to check, maybe I just want to check to see if you have, if your reservation is, let's say, if your order is close to the date of delivery, and I want to send you a delivery email, for example, right? So the first operation would first check to see if you have the email, right? So from the but what I just described to you is essentially business logic, right? And if you have that flow of, okay, I will call the business logic first and then use the output of the business logic to call the I/O operation. The question I'm saying is not all business logic are that way. Some business logic have the I/O operation first, and then and maybe some other computation involved, some other pure computation involved, and then finally a this thing at the end, another set of I/O operations. How would you go about doing something like that?
It's based on my experience. You're still having all that in the controller. So let's think of an example.
Okay.
Hold on, you said something about email. What was that example?
Yeah, so say for example that, okay, I've purchased an order, right? Or maybe I click a button and it will first check to see if the date of the, if my order will soon be delivered. Maybe I'm 3 days or 4 days away from the delivery date, and then send an email based on the fact that, oh, it checks, and if it checks and doesn't see any if it checks and sees that, okay, the email, sorry, that my delivery is still like a month away, it won't send any email. But if it checks and sees that, okay, yes, my delivery is close, then it should send an email. Imagine that kind of operation where there is I/O, which is checking to see if the order is within a particular date. Then there is the business logic, which is the validating and all that. Then there is a conditional I/O operation that happens at the end. So it may or may not happen. You get what I'm saying?
Yeah, but I think so. But for me, the way I would implement it is it's still your controller's the orchestrator, right? It's going to say call this function, and if this function is successful, take the result of this function and feed that result into this other I/O operation, and pattern match on the result of that. And if that's successful, then take that result and pipe it to this other operation. So your controller, I look at is like the orchestrator, right? It's it, if you want to keep I/O at the edges, then what I've learned is your controller, I would argue, should be the only client for calling your domain operations. I don't think it. That's just what I've learned so far from practicing this stuff. And your because your controller is imperative, it's going to return results, and it's going to be rendering those results to UI, and it also may be logging events for auditing purposes. And so it's just a client, and that's all it's doing is just call this operation. Oh yeah, this operation is good. All right, call this next operation. And so if you're using like a functional programming paradigm, you'll see, like, the more you do pattern matching based on the result, take that result, pipe into another function, pattern match on that, take the result, pipe into another function, it'll start indenting further inward. but that's been working for me.
Because
I'm not sure if I answered your question, but I think I know what you're asking. I wish I could give you an example.
You did, but the counter argument there is like I try to avoid as much like orchestration inside my controller, because imagine if I had another app, right? Let's say I had a mobile app that was supposed to still, or maybe a background service or something that was still supposed to use the same logic. I would have to duplicate that orchestration in all the different app types, essentially.
Yes and no.
Okay.
Yes and no. I'm trying to. I want to show you an example of what I have, and maybe it'll be a little clearer. So, I have
Yeah. Let me switch your on screen. Should stop sharing. So let me see your on screen.
All right.
Wow, what time is it over there?
It's 1:30 p.m.
Wow, it's 7:30 here.
I think you guys have the same time as London. I thought London was 6 hours ahead of us.
No. Actually, I'm +1. So I'm 1 hour ahead of London.
Oh, okay. So you see my screen. Hold up.
Yeah, I can see your screen.
What do I have? Let me close this loan management. Let me close this 7. One second. All right, so let me try to find a view model that is relevant for your question that you're asking.
Yeah.
We have our property. No, see, none of this stuff has been implemented. These are the commands on my view model where someone presses a button. Request ride is so like here's my version of dependency injection, right? I hate IOC containers, right? So I hate it with a passion, but so this is kind of like what I'm referring to. So this request ride is more than likely a result of a command. So when someone hits a button saying, "Hey, I want to request this ride," then the first thing I do is ask if it can request, which I'm sure is still a function within. We'll just write it. Can request is business logic in my view model, only because it's relying on certain values, certain view model properties, right? Okay. Now I could just as easily move this, and I probably could move this can request to some domain function and then pass in 3 different parameters.
Oh, okay.
And it's probably better that way. I could probably do that, but to me, it just wasn't that relevant. But for this request ride, I first call one function saying can request. If I can request, then I immediately do some side effects, right?
Yeah.
So I assign some quote to this ride property. And then from there, hold on, I call this request ride. This ride is actually a function, right?
Okay.
And the result of this function called request.ride, in which I pass in the quotes for that ride, I do a pattern match on if it's okay or if it's error. So this is my IO right here, right? This is request.ride is my IO function. If I drill into that, this is a record type that has different functions as properties.
Mm-hmm.
Okay.
Okay.
And so that does IO. I pattern match on if that IO request that I made was okay, or if it's error. If it is okay, then I take the result of that successful operation call, and then I
Pattern match on that too as well.
I do some more side effects, and then I take this and I call another function in here called, well, that's not a function, that's
That's
discriminated.
a type.
Yeah. But then I call it
Constructed.
broadcast too, which is kind of like a subscriber pattern. This probably isn't an
Mm.
ideal example, but I mean, this is kind of what I meant to describe
Yeah.
as I just have a chain of functions, but I just pattern match and then call the next function based on the result of a previous function, if only if it was successful or not. So I know like
Okay.
that example kind of sucks. I wish I could find you a better example. Let me go to it right ended.
I kind of get the idea here. I think I understand what's going on. So,
And so here's the main driving point of the decisions that I've made is where's scope to this at? Is request price part. Did I have anything in there?
hey, what technology is this? This is Xamarin, right?
Yeah.
Okay.
Yeah. I mean, all my stuff is pretty short, right? I don't have, but which is something important to highlight is this is a client side application, and I think your perspective is a back end application. And so,
Yeah.
what I mean by that is a client side application, you just have buttons and list views, and you tap on a button or a list view item, and some operation occurs, and that's it. And you render that operation, or you render the result of the operation as a user interface, and you might save some data. But like on a web service, there may be like some series of operations that need to occur off of one type of command, right?
Yeah.
And so, yeah, it's probably going to be different, what my view model is doing versus what your controller would be doing. But I still kind of think that your controller should be calling both safe operations and or should I say calling both pure operations and also impure operations, and just taking the result and keep piping it to other operations, just because there's been enough people that claim that you should keep your IO on the edges of your domain model, or I don't know how to say it. They say that you should push IO operations to the edges of your architecture, something like that. You know what I mean?
Yeah, I get what you mean. Makes sense.
I'm sorry for not being able to answer it.
No. I have like going over it again. Like I have some ideas of how I would tackle this on the server side. So, what comes to mind is I may in my controller instead of no. So ultimately, it makes sense. In my controller, I'll just call the different functions for both pure and impure. But it will probably be what would probably happen is that I would use dependency injection. So say, for example, my IO operations, I will pass them as functions into my business logic operations. Then in my business logic, I can now have the sequence of operations that I want to perform. Make sense?
No, you got to repeat
it. So yeah. Let me share my screen one more time so that I think I will use this thing to do it. I will use sure, let me use Linkpad because why not? Have you used Linkpad?
I think the disconnect that you and I are probably having is you're making the argument that I shouldn't. You're making an argument that there should be a bare minimum amount of logic in your controller or in your view model, and
Yes.
and I agree with that. But then my argument is your view model or your controller is the imperative shell, and it relies on a functional core. And so your view model or your controller, it's 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 invoking functions that are siloed in a separate library. Like it's triggering your business logic, but at the
Yeah.
same time, I still think that your controller or your view model is responsible for performing the side effects, right? Your controller and your data gateway libraries are responsible for doing side effects, and so like I'm not sure where else you would put that logic.
Yes.
I don't believe in having a 1,000 line controller. I agree, um, but I also think that your controller is just it's it's kind of imperative programming, right? It's calling a pure function, taking the result, rendering or calling another function that's going to be saving stuff, and that's its job. To me, I mean, people would argue, but it's processing the result. It's dispatching what someone wants to the domain model, and then taking the results and and rendering those results back or converting those results so that the client of that controller can do something useful with it. And yeah, I mean, I don't think it's handling business logic. I think it's handling the orchestration of how business logic should be executed.
So this is, let me show you what's going on in my mind, right? This is what I think it should be. So just give me a moment. Let me just problem after F6. Good. Now let's say I have this. Let's say we have the app, right? This is the controller function, right? Let's say this is the controller function that does something, right? And we have access functions. Let's this one says get users, right? And it also, okay, I don't know if you can see. Can you see my screen?
Yeah, I see it.
Get users, then we have this one maybe okay. Let's use the email example we said, right? So this one will say send email, right? And there will be one that will say get orders, right? Something like this. Okay. And then I would have let's call this operation notify, right? This is the notify operation that's supposed to notify essentially the business logic for sending notifications. So first we get all your orders. Let's say it takes a user ID. So let's create an IPF user ID. Right? User ID of equal to user ID of int. Okay. So here we take user ID. Let me do this one. So take the user ID. And but more importantly, so at the controller level, right, you would essentially so what you are saying is this, right? I would first do get orders, passing, let's say the controller retrieves a particular user ID, right? E of 10, and then get orders, we pass the user ID. F# now has a own it has results of T success, T failure now. So let's say result. Let's say order string. Let's go ahead and create an order. Let's say whatever. Yes, this. So I know it's somehow to be watching me, but okay. I don't see CVDM, but let's say this just becomes okay of right. So to list the email also does say okay of string, okay of sense, right? So what I'm getting at in essence is these are two like impure operations, and this is supposed to be one pure operation. And this pure operation, right? We would do two things. First of all, we need to first call get orders, but we can't do that because we can't depend on this get order. So we would pass essentially a function that would say fetch orders, right? Something like this. It takes the order list, right, and returns, or better yet, we would have a type here. So I'm now integrating what you just explained to me. So there will be a fetch orders operation, and that will take an order list and return results. That will take the user ID, and return order lists and string, right? And then, oh, okay, this is supposed to be equal to not. I'm missing something. Am I missing something?
Okay. You didn't define what an order is.
Yeah.
Or did you?
Okay. No, I didn't. So this would take this fetch orders, and it would also take a send email, right? So we would also implement that type says send email. It takes what would it take? It would take let's say it would just take a single order, and then it would return the results of string. Results of string, and something like this, right? So this is what I'm getting at essentially. So what you are saying is I would first call get orders. So this send email, let me just make it return let's say it takes a string. Oh, let's say it takes so yeah, pretty much. I think we're done here. So let me cut this out. Let's leave this the way it is. But what you're saying is I would come here and essentially call this method that has the side effect. Okay. And it was supposed to take a user ID. Sorry. ID, pass the user ID, and then I would essentially pass it to this function. Would essentially pattern match and say if it was okay, the results are, what would I do exactly? Yes.
Well, so the question is, are those operations mutually exclusive, or does one operation depend on another one?
Yeah, it does depend on the other one. So that's what I'm trying to get at.
Yeah,
so
if that's the case, then yeah, that's kind of what you're typing out right now is what I've been doing. And okay. I personally don't see anything wrong with that approach.
No, there's nothing wrong with it per se, but I want to show you where my mind is at.
Okay.
And then now compare notes. right? So I want to first implement yours, and I'll explain how I implemented mine. I'll also even show you the downside with my own approach and part of the reason why I kind of give up. So let's see, send email first. This I now pass a function where it takes, and if it's successful, I okay. If it's send email first, I won't just pattern action it. So I would first, okay, let's say, like I said, we'll check the order amount. So say if first dot amount is greater than 5, for example, then it should invoke the second one. So that would mean calling notify. Sorry, not notify. That would mean calling send email and then passing the order. So let me rename this to that first to order, and then something like this. Just this is yes, we call send email. If you did, what should happen? Else, what should it return? It should return the okay. I'll get to this in a moment. Let me just put unit here. But what does send email return? A result of it returned OK of unit. Okay? OK of what? OK of nonsense, whatever. Just spitballing here. Just but the idea would be I will now call send email, pass the order, then for successful OK message. Just return this straight. I don't even need. This essentially does what I expect, and this is a controller function. So let's say just invoked it. Why are you unhappy?
Because you don't have an error.
Yeah, the unit at the bottom. Yeah.
The other part that I think screams, and maybe this is what you're alluding to, is maybe this what the problem that you're trying to solve can benefit from the railway-oriented programming that you talked about earlier.
Yes, but it's not just that. I think the problem exists anyhow you look at it. It's just in my own implementation, I shifted it to this function, but you will soon see from my own implementation that the problem is still there. It didn't go away. It's just, a reshuffling, if you will. So let's say this one, okay, sure, error message, okay, not sent. So let's just say error message down here. So, two things, right? First of all, yes, we are calling all these methods. This makes our life a lot simpler because all we would need to do really is just have our IO functions, and by defining them up here, we just invoke all of them and we're good to go. And it's a lot less coding to do. It's a lot less abstraction. If someone comes to this controller, they understand exactly what's going on. So those are some of the strengths of this approach, right? Because you want your code to be as clear as possible, because by the time you are looking for bugs, right, it makes your life easier if you can just quickly see what's going on. I think the downside is that if I had like 3 different application types, I would essentially have to repeat this code 3 times. Say, for example, I had maybe a web, a mobile, and a desktop app for the same application, right? I would, because I'm assembling all the IO operations in the controller, I would have to repeat this code 3 times, right? So how I used to avoid this was to come here, this user ID, right? And I would essentially pass the 3 functions. So there'll be fetch orders here. I'll call here. There would be send email here, right? I would call here. And then I would now move this logic essentially. So I would move this logic here. Pretty much is get orders, blah blah blah. Give me a moment. Yes. So this would actually be fetch orders. Right? So exactly. And what I would now do was to come here and construct. I would first construct like a higher order function. So I would say notify. Would I do that? Yes. I would say something like let's notify user be equal to notify. Then I would pass get orders. And I would also pass send email like this, right? Typically, this would be done probably outside of the application. And then I would just come here and call notify user, passing the user ID, and then pattern match on that. Function, simply just say match and say okay, the value here, and then whatever and error case as well. MSG, and put the value here as well. The downside with this, so you get how I'm shuffling it. The problem is still there. It didn't vanish, right? So I still have my I still have the business logic in one place. So the advantage is I could call this from multiple application types. The downside is that this method signature will get very complicated very quickly. So imagine it was 5 operations I wanted to do. Yeah. So imagine it was 5 operations I wanted to do. Does it mean I would have 5 methods here?
No.
Aha. So that's
you could pass in a record.
Okay.
And a record will expose properties of function types.
Oh, I see. So something like what would I call this? I would call this manager.
Or you could pass in a list of functions. But those lists of functions would more than likely be tightly coupled to some type of discriminated union.
Okay.
So that it could be compilable. But I would say that it's more configurable if you create a record type of functions.
So something like this, right? Then I would essentially just eliminate this here.
That's what I do in my applications. I just have record types that I inject.
Okay. So this is processor, and this would just take order processor, right? This would work. Oh. Man, Scott, I've learned something.
Cool.
Yeah. Okay.
The only reason why I was kind of quick to say record type as a property of functions or a list of properties for calling functions is because I've been doing a lot of C#, F# interop, and this is a viable technique so that you don't have to create all these crazy types in C# just to call a function in F# or process a result in F#. So
interesting. Nice. Yeah, I think I gained something today.
That's cool.
This is cool. Yeah, especially this, because part of the problem that I was facing was, imagine this, but with like 10 functions, and each of those functions had crazy signatures like these all over the place, and it was just it was so painful to manage. So, but now that you mention it, like this is a lot cleaner, like orders of magnitude cleaner, because now someone who sees this knows that okay, this is an older processor, and this has like functions like this. And if I wanted to swap out the implementation, right, at this point here, I could essentially pull out the function. So this function, this get orders, right, could come from, I don't know, this particular function could come from a different assembly as pure. These functions here could come from impure assemblies, you know, from like an infrastructure assembly or something like that. And then assembling it here and then just, you know, calling this with. Huh. Huh.
Okay.
Huh. All right, cool.
Something doesn't look right with. I know all this is example code, but
Yeah.
the notify function at line 13,
Yeah.
it the error message yields error message. Is there any alternative?
Oh, yeah. It's actually simply to just say
Just X and then
it's goes to
X,
X. You know, pretty much.
or is
Wait
it
a
called
minute.
ID? Like what if you put ID X? I forgot how to get that compile. Type in ID space and then X. No. That
Mm.
not that, but X right there, and then yields, and then just put ID in front of X. I wonder if that will resolve the compilation there.
No. It won't. I think what's going on here is that this is a result of order to order list and string, whereas notify is string to string here. So yeah, I think yeah. No,
It should just be X then.
not really. This is
Like that just doesn't look right to me, but okay.
yeah, because
Or if you put a okay.
hold on. Huh, I think I get what you're saying. Make this X, right? So make this X. It's actually still result. Okay. This.
Because yeah, I thought that you could. I thought X would be a variable. Yeah, it doesn't matter. I don't know. It just looked strange to me.
Okay. I think I see what's going on here. You see this fetch orders, right? The type signature here doesn't match this type signature here. That's why it's not working.
Okay.
That's why I can't simply just say X, because the thing I'm returning is of a different shape. Like the success aspect of it is of a different shape than this. So by coming here, and even though the error message is of the same type, right? That's why I'm forced to do this.
Okay.
Okay.
Cool.
Yeah.
I think we covered a lot in this session.
Yeah, we did. Although, yeah, this would say. Just give me a moment. Instead of having a function,
I almost never use match anymore. I always do the pipe to function reserve word.
okay.
No, look. So hold up. Processor dot fed. You know, there's an alternate way of writing that, right?
How?
So, take
Oh,
your copy and
okay.
paste line 14.
Okay.
And put it on line 13. How does this work? After the equal sign, I think. No.
Okay. Yeah, like this.
And so delete the match.
Okay.
And take the period after processor. And you should be able to hold on. How does this work? You have okay. Now put the period back, and replace the with the pipe operator.
Okay. Like this.
And then you could delete the matches underneath.
Oh, okay. And good function, right?
Yeah.
Okay. I can
I don't know.
even
That's
take it.
probably uglier, but I don't know.
No. This. I could take it a step further. I think I get an idea of what you're saying. So
Yeah,
I could
it
do
doesn't matter.
this,
But
then do it like this, and do it like this, and do it like this. That break?
you got to push that over, tap it.
Yeah. Okay. What?
It's been real.
That is cool.
Well, thanks for getting me
I
hip
think,
to Thanks for getting me hip to Kubernetes. I'm probably going to read the book.
yeah, you should. You really should.
I want to make money, man, and they don't want to pay me money for doing mobile app development. Not the kind of money that I want.
Oh, okay.
Yeah.
I don't know. I think backend is where it's at, though.
Yeah.
Mostly backend systems. But on a serious note, take a very good look at Kubernetes, Docker and Kubernetes. You'd be pretty much. I don't know if you'll be mind blown, but I was mind blown anyway. And considering that I've been using it for close to 6 months now, like it has a steep learning curve, but once you get over that curve, you start to see the beauty of it. Like there's a lot of beauty in it, you know. And also, it also eliminates this idea of okay, I have to stick to one runtime or one stack. You know, you can use whatever stack you want, and you can mix and match stacks however you see fit. So maybe you have a machine learning component of your application that you want to write in Python for whatever reason. You can just package that Python machine learning application into a container and then add the container as part of your deployment, and then your apps can talk to the Python service and get responses back. Essentially, abstracting out all the difficulty of standing up individual web apps. That's essentially what microservices are: individual web apps.
Okay. Yeah, I bought the book, so I'll read it. I'm not how long it'll take for me to actually. The only real way for me to actually like learn and immerse myself is to probably start blogging and live streaming me attempting to practice it, which is probably going to be scary. But
yeah, I think maybe what should happen is whenever you want to start working on it, just give me a call. Then you and I can sit down and session where we are, walking through the whole Kubernetes stuff together. What do you think?
All right, it sounds good.
Yeah,
I probably won't go full throttle probably for like another 3 weeks.
Okay. The reason is, I've learned a lot of neat tricks and tools that I think will help shorten your learning curve. So.
Okay. All right, Odie. I'm starting to tap out. My concentration is like starting to my cognitive load. But it's been real. Thanks a lot for sharing this stuff with me.
No props, man. Thanks a lot too.
Yeah, I'm hitting the stop broadcast button.